You want to see worked off the packet?
The whole second.
24, 23,
The whole second page.
23.
Can I ask you a real quick question?
What?
Okay, on number 10, I did this one, but like, I took the square root of 11 and then squared it. Is that right?
Might be. Just ask me after this one if you want to see that one. First thing, and we're going to do these again today, so the packet we do today, same kind of stuff, dealing with Pythagorean's theorem, a lot more of the radicals. First thing you should do when you're using any of this chapter, first thing I always do, draw that arrow. How come I draw that arrow from that box? That's where the hypotenuse is. You gotta find the hypotenuse in every one of these. Now I don't care if you, right now I don't really care if you label it or not, but you gotta know where the hypotenuse is at every single time in a right triangle. Always. That's gotta be the first thing you do. Pythagorean's theorem is a squared plus b squared equals c squared. Remember, a and b are your legs. C is your hypotenuse. So what am I going to put in for C this time? 2. So 2 squared. What do I put in for A?
Square root of 3.
Now watch, because a lot of people are letting these radicals confuse them. Don't. You're just going to square that just like you just, ignore that, just like you just squared that 2. What goes in place of B this time?
B.
Don't change it to an X or a Y or any other variable. We'll just leave it. Makes it harder and more confusing. Then you don't have to. Over here, what's 2 squared?
4.
That's pretty easy, right? B squared stays B squared.
That equals 3.
Ignore that. What happens here with the 2 and the radical?
Cancel.
You gotta know this. This is gonna make everything easier for the rest of this chapter. That 2 and that radical just cancel out and you're left with just the number that's underneath the radical. Do I still have to take the square root of 3? No. Do I square 3? No, it's just a 3 now. Now what do I do?
Minus 3 on both sides.
Minus 3 on both sides, good.
B equals 1.
You end up with b squared equals 1. Now what do you have to do? Take the,
Square root.
what's the inverse of squaring something?
Square root.
Taking the square root. Take the square root of that side. If you take the square root of this side, we gotta do the other side.
Square root of that
1.
What happens over here with the b?
one. Cancels.
That cancels with the 2, and you're left with just b. What's the square root of 1?
1.
What's the length of this leg right here on this right triangle?
1.
1. That's your answer. Next one. What's the next question?
186.
My triangle doesn't look a whole lot like theirs, but just go with it. What goes in for C this time? Radical 18, square root of 18, however you want to say it, it all means the same thing. Make sure you square that. What goes in for B?
4.
4. What goes in for A?
8 squared.
A squared. Does it matter which one A and B is?
No.
No, it doesn't make any difference. A squared is just going to stay A squared. What's 4 squared?
16. That's 18.
These cancel out and you're left with just 18. Now what?
Minus 16
Minus 16 on
on both sides.
both sides.
A squared equals 2.
These are the ones that everybody's having trouble with, is because you've gotten used to in the past whenever you did Pythagorean's theorem, you knew the 2 legs and you were always trying to find the hypotenuse. All right? Now it could be anyway. That's why you got to pick out the hypotenuse first. You end up with a squared equals 2. Now what?
Take square root.
Take square root. Now watch. Because Gunnar, I'm going to make your life a whole lot easier. On the left, we got just a, right?
Yeah.
On the other side, we got the square root of 2. Is that going to come out to be a nice even number? No. Will it break down any? Will it simplify any?
So just leave it.
No. So just leave it square root of 2. If you leave your answer that way, that'll be fine.
Can we do number 28?
Does everybody understand that before I go on?
Yeah.
Just leave it that way. Now, Natalie, because I always have students that say this, but it's easier if I take the square root and put down the decimal.
How?
How? That's an extra step, right? If it comes out that way and you know it's not going to come out even, then just leave it that way. Now, the one thing I will say, because I'm pretty much a jerk, if you're doing this on the EOC test, the end of course test, or ACT or something, they might leave your answer just in radical form, nothing else, all right? And some of you might have the Casio calculators or some of the TIs. Is yours a Casio? See, I think on Hunter's, let's see here if I can get it to do it, see if it, I'll find the on button first. Let's say we're going to do this. Square root of 18. So Hunter's gives us square root of 18 is 4.222. See here. So that's square root of 18. Here's my number. Most of the Casios do it.
Fraction and decimal?
No, some of the Casios, just hit clear. Some of the Casio calculators have what's called math print. And what it will do, and Hunter, you might be able to find it on there, because it's probably on there, because I know if all the other Casios have it, that probably has it. But it's usually under mode, and I didn't see it. It's called math print, and what it does, when it gives your answer, when it would give an answer like this, instead of giving the answer as 1 point whatever, as a decimal, it would leave your answer as radical 2. All right? So if we had something like radical 75, what I started to say, if Hunter can find this on his calculator, he'll be able to simplify that by using his calculator instead of have to do it out longhand. Does anybody remember when we were simplifying square root of 75? Instead of just grabbing our calculator and giving me 8 point whatever it comes out to be.
Okay, that's 25.
You break it down into a perfect square number. What's a perfect square number that'll divide into 75?
25.
25 times, what times 25 gives you 75?
3.
Then we take the square root of this first one, the 25. What is the square root of 25? So that comes out of the radical. What stays under the radical?
3.
So 5 times the square root of 3. This, and that 8 point whatever, if you did it on your calculator, all three the same answer. This is probably the best answer because it's in simplified form and it's exact. And there's going to come times throughout this chapter when I'm going to say, give me the exact answer. I don't want this decimal answer because what do you got to do to that decimal answer? Round it off. All right? This right here, a lot of books, a lot of math books, which I don't agree with, but that's why I work at Trail, not some, big, huge Harvard or something and make all the math rules. A lot of math books now are just leaving the answer radical 75 instead of simplifying it down. Okay? And they're doing the same thing, and you guys probably, like this. You'll see a lot of fractions now just left like that, 3/6. What's wrong with that? It should be reduced down to 1/2, right? And that's the way you were always taught. Well, some of them now are saying, why reduce it? Just leave it that way. Which I think is just laziness, but,
Can we do
all right,
28?
28.
I got 0.
So I got the
Did you find anything on there?
I got 0.
Hunter, did you find anything on there?
20 for,
I don't think that's right.
Maybe during intervention, get it out and let me see it and I'll check it out and see if I can find it. I know all the other Casios, they've all had them on there. 28, is that the one you said, Bobby?
Yeah.
Anybody tell me anything special about this triangle?
It's a right angle.
So equal left.
Oh, they're all right angles. Does that have a, never mind.
Got two equal sides.
It's got two equal sides. What's that mean?
Isosceles.
It's isosceles. We're gonna learn later on this chapter, this is called an isosceles right triangle. In an isosceles right triangle, we're also gonna call it something else. If these two sides are congruent, what can you tell me about these two angles?
They're congruent.
They're congruent. How much is this angle right here?
45.
45. How much is this angle up here?
45.
We also call this a 45, 45, 90 triangle. Oops. 45, 45, 90 triangle. For obvious reasons, right? In a 45, 45, 90 triangle, later on this chapter, I'm going to tell you this. In a 45, 45, 90 triangle, the two legs are always x and x. This hypotenuse, the side across from the right angle, is always the length of that leg times the square root of 2. So instead of me using Pythagorean's theorem this time, what's x if I'm looking at it this way?
24.
24. What was square root of?
Square root of 24, good. And I'm going to take that, and I'm going to times it by what? If I put that in there for x.
Square root of 2.
So it's going to be the square root of 24 times the square root of
2.
2. What is the square root of 24 times the square root of 2?
6.92.
Ah, don't do that.
It's 48.
48, square root of 48. I want the exact answer this time, no just decimals, all right? Let's use our brain a little bit and not just grab the calculator. Give me a perfect square number that'll divide evenly into 48.
12.
12 is not a perfect square number. What are the, let's make a list up here.
4.
4,
8. No, 6.
16.
come on now, how do you find the perfect square numbers? This is easy.
4.
2 times 2 is
4.
4, what's next? 3 times 3.
9.
Then what?
16.
16, then what?
25.
Then what?
36.
Then what?
49. 64.
49. That's probably about as high as we need to go because that's too big for what we have, right?
Yeah.
Any of those divide evenly into 48.
No.
Grab your calculator. Now you can grab it and find out if it divides evenly. I don't want to know what it is. Just, will any of those go in there evenly? 16 will?
I'm not sure what you said there.
16 times what? What is the square root of 16? 4. And we still got the square root of 3, right?
Yeah.
That's the best answer for this problem.
Okay, so is that why I got
4 times the
0
square
when I
root of
did-
3. No, I don't know what you did if you got 0.
No, because I did.
Let's
right-
set up Pythagorean's theorem.
Yeah, that's fine.
Which one's the hypotenuse this time? The one we don't know, right? What goes in place of A?
That's what I did.
Square root of 24, and then we gotta remember to square it. What goes in place of B? Square root of 24, we gotta remember to square it. What happens here with the square root and the 2? Cancel out, you're left with just 24. Same thing here, right? 24 equals c squared. C squared equals 48. Now what do we do? Take the square root. And that's the same thing we just got done doing over there. Taking the square root of 48. Now if, on your paper, if you gave me the decimal answer because I didn't specify, give me the decimal exact or whatever, probably won't say a whole lot. But know at some point throughout this chapter, I am going to ask you for this kind of answer, an exact answer, not just some decimal answer that your calculator gave you. And if you give me this answer, probably on the test, if you give me this answer, I'll probably just take off 1 point. All right, so you get most of the points, but I'll take off 1 because you didn't reduce it. Now again, on like the ACT test, they might accept that as an answer on some things, or the end of year test. They might accept just square root of 48 because a lot of books don't reduce them now.
You know, the new test, they're doing keyword stuffing, so we don't actually have to write like exact answers, we just have to write certain words.
Really?
Yeah, cause
That's
the
just
computer's
people.
grading it.
That's just people being lazy and not wanting to grade
So
it.
you just literally could just type just the keywords and get
So you could put
100.
Pythagorean and
Yeah.
stuff like that, and then it's gonna say, oh yeah, they're right, and it won't make any sense whatsoever. Other questions?
What about?
29.
29.
That's what I was gonna say.
We're not getting to a law, are we? Seemed like we were a little. 29, a tent is supported by a guy rope. Does anybody know what a guy rope is?
No.
It's a rope that's attached, or a wire that's attached to something to sort of hold it up.
Oh.
Okay? So when you see those wires coming down from telephone poles and stuff that hold it in place, that's called a guy wire. That's what a guy wire is something that holds something else up. Tied to a stake, as shown in the diagram. What is the length of the rope? Now, what we need not do, and what I'm afraid that Silas does sometimes, is he looks at that picture and then he gets off track and goes, God, dude, that's a crappy tin. It's got a patch on it. And, and he goes through all this stuff, and then he forgets all about what he's doing. Does he care at all about the tin? No, all he should care about is that triangle right there. Does everybody see the triangle that they sort of drew in there for you? And sometimes you might have to draw that yourself. They tell us this is 8 feet, this is 6 feet. They want to find this. Here in a few minutes, we're going to go over something
Perfect triangle.
that's a 3-4, it's called a 3-4-5. It's called a Pythagorean triple.
Oh, there's so many names.
With the Pythagorean triple, what this is telling us is that anytime we have a triangle and it has a side 3, a side 4, guess what the other side has to be?
Right.
5. All right? Which one of those is going to be the hypotenuse every time? The 5. That's always going to be across from the right angle. This actually fits into that family. I call them families. They just call them Pythagorean triples. But I say this sort of fits into that family.
So there should be 10.
Because if I look at this, why it's going to help us out here. What I do to 3 to get to that? Double it. What I do to 4 to get to that? Guess what you got to do to the hypotenuse to get to the answer over here? Double it. So how long is that hypotenuse? 10 feet. So that guy wire has to be 10 feet. Is that going to make your life a little easier if you can recognize some of these Pythagorean triples and not have to do all Pythagorean theorem and everything every time?
Yeah.
Yeah. Next
Can we do
question.
32, please?
32. Oh, and the other thing I'm going to say, I didn't really look at the end of year test last year, but I know on all the other tests that they've ever done, OGT and whatever that other test was that we did for a couple years, all those other tests, see this 3, 4, 5, they use that continually. If they're putting a right triangle in there, it probably fits into that triple, into that family.
We can use that for like any.
So I need to like
So-
write that down on my arm before the test.
So if they give you a triangle and you're looking at it, and they tell you this side's 500 feet, this side's 300 feet, what can you tell me about that leg?
400
It's
feet.
400 feet. Do you have to use Pythagorean's theorem?
No.
No, if you did use Pythagorean's theorem, would it be okay?
Yeah.
Yeah, as long as you make sure you remember where the hypotenuse is at and everything else. Now I say that because I'm looking at this next one. This is number 32. Is that the one you guys said?
Yeah.
Yeah.
I got a rectangle here. And we're gonna put these braces in. I'm just gonna draw one of the braces. What do we know about this side of the rectangle?
It's 12.
12. What do we know about this side?
It's the bottom one, but.
Because it's a rectangle, bottom or top, it's the same thing, right?
Yeah.
16 feet. Forget that this is even here. Let's get rid of that. We just want the one triangle. This is a right angle right here. Let's hope if we're building something. Does anybody see something there?
Yeah.
It's a.
Fits in that 3, 4, 5 again, doesn't it? This is 3 times what? 4. This is 4 times 4. So, that's supposed to be 4 times 4. So this one's gotta be 5 times 4, which is 20. So how long is that brace across from corner to corner?
20 feet.
20 feet. Now, I guess I better read the question. What is the length of each brace? Now, that's what we just found. Just had to read it to make sure that they didn't ask us something different than. If you look at the one right above that, the 31, that fits into a family too, that we're gonna talk about. Not the 3, 4, 5 family, but it fits into a different.
Then can we do that one?
What is it? 7? Does everybody agree with that? So guess what the family is? Instead of 3, 4, 5, it's
3, 4, 7.
7, 24, 25. So what if I gave you this triangle? Told you this side was 14, this side was 50. Anybody find that side for me?
48.
48. Because what did I do to the 7 to get to this 14? Times it by 2. The hypotenuse, what I do to 25 to get to that 50? Times it by 2. So what are you going to do to this other leg to get to here? Times it by 2. One more. 30. Problem 30, make sure your names are on these, you're gonna pass them up here in a second. Problem 30, if the supporting stake in problem 1 were 15 feet from the tent and 8 foot, and an 8-foot tent pole were used, what would be the length of the guide wire? So
Do the same thing except for just change.
what is this right here? This distance? 15 feet. What's this distance? 8 foot. This over here is our guide wire, right? That's what we're looking for. Ignore all the stray marks that my pen's putting up there.
You can use the 3, 4, 5.
Now, does it fit the 3, 4, 5 family? No, it doesn't. And what you gotta figure out when you're using these families or these triples, the shortest leg has to go with what in the 3, 4, 5? The shortest, which is which number? 3. 3 times what gives you 8? Nothing. Right, some decimal, right? And that's not what we want. So does it fit into a 3, 4, 5 triple? No. Now, it actually does fit into another triple that we're going to talk about, but you don't know it yet. So, so we just use Pythagorean theorem here. What am I going to put in for the hypotenuse this time? Because the hypotenuse is always across from the right angle, and I don't know it, right?
Yeah.
Make sure you draw that arrow in. Because I heard a couple of you getting ready to say 15 because it's the longest. But that's not the hypotenuse. The hypotenuse across from the right angle is one we don't know. What goes in place of A this time? 15. Does it matter? No, it could be either one of the 2 legs. What goes in place of B then? Take your calculator and do all that math right there. These are the easy ones. You can plug all that right into your calculator and do it all at once, unless you have one of the calculators like Wyatt's. Then you got to do it separate and make sure you add them together.
200.
Don't give me the whole answer. You got what?
289.
289. Anybody else agree with that? Now what do we do?
Take the square root of 289.
Now you take the square root of both sides. These cancel out. That leaves you a C. 17. Anybody tell me what the name of this other Pythagorean triple is? 8, 15, 17. That's another one that we're going to talk about here in a minute. So these are Pythagorean triples are ones that where it comes out as whole numbers anytime you're dealing with a triangle. The 3, 4, 5, if you have a grandpa or a dad or something that's into doing a lot of construction, if they work in the construction business, you might hear them talk about the 3-4-5 triangle all the time, because anytime you go to build something, a lot of times you'll base it off of 3-4-5. Now, if I'm building a house, am I gonna make it 3 feet by 4 feet and then have the diagonal distance across here be 5 feet? No. But if my house is gonna be 30 feet wide, to make it easy on myself, could I make it 40 feet long? And then what should this distance be from opposite corner to opposite corner? It should be 50 feet. And I can measure that, and if I measure that, that's gonna tell me whether this angle right here is a what? A right angle. Is it important for that angle to be a right angle? Yeah, when you're building a house, it's very important. If this is a right angle, and I know this side's 30 and this side's 40, what's that tell me about this angle over here? It's a right angle. What's it tell me about this whole angle right here? It's a right angle. How about this one? Right angle. What's that tell me about my shape? It's a rectangle. 110. 110. Make sure your names are on those. And pass them forward, then pass them over this way, and have Sam end up with all of them. Get out the notes that we started taking from last time. The notes that we started taking last time started off with this Pythagorean theorem. Sam, have everybody's? Is that a yes? Yeah. Notes from last time, get them out.
I'm glad it is. So you're gonna select harder and darker and curves.
There's an Amber alert on my phone today. You guys been kidnapped.
Yeah.
I got it.
Yeah, I got it. His phone flashed on Silas and sent him a vibrator for like 5 minutes.
I know, I seen you screwing with it.
I don't think I get Amber alerts.
Somebody has this part of the note.
Yeah.
Oh, I got it. Oh, yeah, I just got
That's what
that.
happened to me. That's what my.
No,
Let's go. Over with down.
We already have that.
Pythagorean theorem.
We have
We
that.
talked
We
about
have
that. Bobby, I heard you the first time. I'm
That
not.
wasn't even me, that was Natalie.
Natalie, I heard you the first time.
No, it was me the first time, it was furthest.
Sorry, Bobby.
It's okay, I'm used to it.
No, you're
Everyone
not.
blames me.
Bobby can hear me when I screw up. With Pythagorean theorem, it only works with right triangles. You've got to draw in this arrows. Everybody see this arrow right here? You've got to start drawing it in and know where the hypotenuse is every single time. That's where your Pythagorean theorem isn't hard. It's just you get in a rush and then you don't set things up right. Makes you know which ones are the legs, which one's the hypotenuse. What do we know about the hypotenuse?
It's the longest.
It's always the longest side. So if I came up with something like this, if this side over here was 3, this side down, or this leg down here was 12, and I did Pythagorean theorem and I came up with this as 10, what do I know?
10 is.
It's a triple.
What do I know? If I came up with my answer and it was this 10 right here,
It's not right.
it's not right. How come?
Because it's not longest side.
It's not the longest side, so I messed up somewhere because this hypotenuse better be longer than what?
The base.
Got 12 down there. Make sure you check your answers, make sure they make sense. Alright, write this down. These are the triples I was talking about. Notice how I have them written down. I don't know if you can fit it on your paper that way, all the way across. If not, then skip some space and put 2 of them down below. So in other words, maybe write 2 of them crossed, skip some space, write the other 2 down here somewhere, because we're going to list stuff underneath each one of these. call them Pythagorean triples. To be a Pythagorean triple, it's any three whole numbers that together can fit Pythagorean's theorem. So if I knew that this leg was 3, this leg was 4, we use Pythagorean's theorem to find this, the hypotenuse. What's it going to end up being? 5. That's a Pythagorean triple. I usually call them families because a Pythagorean triple has to be whole numbers, numbers that come out nice and even. But I'm going to show you other ones that fit into this that don't come out nice and even. Might be decimals, might be radicals, might be fractions, whatever. Okay? Give me another one that fits in. We already talked about this a little bit. Give me another triple that fits into the 3, 4, 5 family there. 6, 8, 10. Oops. 6, 8, 10. How many are there going to be that fit into this family? An infinite number. We're not going to write them all down. I'm just going to put down a few examples. So what this is telling us, next time Hunter sees a right triangle and it tells us this side's 6, the hypotenuse is 10. What's he know about that third side over there? It's got to be 8. Now you got to be careful because what if I did this? Told you this side was 6, this side was 10.
8.
Is that side right there 8?
No.
No, why not?
Because it's not.
Because it's not as bigger than 10.
It's not bigger than 10, so sometimes, and would I do that on the test? Would I try to trick you that way? Probably so. All right? So,
It would work on Bobby, but.
so you got to make sure that it fits it right. Give me another one that fits into this.
9, 12, 15.
9, 12, 15. What did Ian do to each of those numbers up here?
3.
Times it by 3. Give me something else that fit into that.
30, 40,
30, 40, 50. Give me another one.
50.
300, 400, 500. These are the ones, these last couple, these are the ones you probably want to be able to recognize it on because you really want to use Pythagorean's theorem and have to square 300 and square 400. Probably not.
So could you do 90, 120, 150?
Would that work?
Yeah.
Yeah. So all those fit into this family. Now, some other things that fit into this family that I was talking about that's not a Pythagorean triple. What if I told you this, one of the legs was 0.3, one of the legs was 0.4. What's the hypotenuse going to be?
0.5.
0.5. Let's write another one in here. I ran out of space. Let's try a fraction one if I can fit this in up here somewhere. I'm going to try to fit it right here. What if I told you one of the sides was 3/5 and the other leg was 4/5? Could you tell me what the third leg or what the hypotenuse is? 5/5. Don't tell me 5/5. That's not a good number.
5 over 5.
It'd be 1, wouldn't it? Because 5 over 5 is just 1. Now, when I throw something like a fraction in like that, is it going to confuse everybody?
Yeah.
Oh, yeah. They're going to be lost. But if I throw that in, so if I gave you a triangle, and I told you this side was 4/5, this side, this leg is 3/5, this one's going to be 5/5, which is 1. If you can recognize that, does it make everything a whole lot easier?
Yep.
Yeah. Now, does that mean that every triangle that we're going to deal with fits a Pythagorean triple?
No.
No. Give me another one that fits in this 5, 12, 13 one.
10, 24.
10, 24, 26.
20,
50.
25,
Give me a second.
60, 65. Huh?
Be writing some of them down so we can go through it pretty quick.
Yeah, but what if they're wrong?
Yeah, and then I'll tell you when we get to them.
Then I
And you can mark them out. Maybe try the third one too and the fourth one. See if you can get a few of those so that we can hurry up since my thing's messing up here.
Can you just see if this one's right, so I figure out where
What is it?
on the second one, 25, 60, and 65.
Sounds right.
That's the projector.
Aren't
Yeah,
you
that's
in that
nice.
hardware class?
Yeah. I think that's supposed to.
Sound no crap. That's why you turned it on.
Yeah, it does.
That sounds like overheated.
Sounds like that because when I turned it off and I turned it right back on, it didn't give it time to cool down.
Were you in hardware class?
So it tries to
Man.
cool it down quick.
Yeah. What?
We could be like really smart in hardware.
No, not really. Just gotta, just gotta know a couple parts and that's it.
All right, give me another one. 5, 12, 13.
The one I just did.
15, 36, 39. Everybody agree with that one?
I guess,
Yeah.
yeah.
20.
20, 48, what? 52. Now,
Let me do it.
probably once we get to something like this one, are you going to recognize that that fits in the 5, 12, 13?
No.
Probably not. All right. So the ones that we're looking at more are these first two, or maybe something like this. Be careful on this one. If I told you the first side was 0.5, what would the second leg be? 1.2. Make sure you don't put 0.12. 1.2. What's the hypotenuse in?
1.3.
1.3. Now again, this isn't a Pythagorean triple, but does it fit into that family? Yeah, and that's the sort of the difference. What if I gave you this? Try something different. 5 times the square root of 3, 12 times the square root of 3. What's that hypotenuse going to be?
20.
13 times the square root of 3.
Okay.
Is that going to be hard? No. But if I gave you this triangle, if I gave you a triangle, and I told you this was 5 radical 3, this was 12 radical 3, and I will do a whole bunch of these, and I asked you to find that missing side, a lot of people are just going to do what to that problem? They're going to skip it. Because they see those radicals and they think, oh, that's too hard. But if you pick up, hey, that's 5, 12, all I got to do is put in the 13, it's going to give you the answer.
Could you do fractions with this one?
I do fractions with this one, so let's go 5 over,
5, but it's 1.
okay, let's go 5 over, let's see, let's do 5 over 13. 5 over 13, what would the next leg be? 12 over 13,
1.
and then the last one would be 13 over 13, which is just
1.
1. Ignore that dirty, stupid thing going through there.
Why don't they give you an word?
How about this? What if I told you the first leg was 5 times the square root of 2? What's the next one going to be?
12. Square root
12
of
times square root of 2,
13 and 2.
13 times the square root of 2. These are the ones that you want to be able to use it on, because do you really want to use Pythagorean's theorem if you're given all those radicals and stuff? No. Now, does that mean, again, is every one going to fit into one of these? Not necessarily. Give me another one, 8, 15, 17.
16.
32, I heard.
45.
40. Don't sound right.
64.
Wait.
We get 32 first.
60.
60,
68.
68. Give me another one.
64.
64,
120.
120,
136.
136. Now again, are you going to pick that out? If I give you a triangle where one of the legs is 120 and the hypotenuse 136, are you going to say, oh yeah, the other leg's got to be 64? Probably not. All right, give me another one. Do a decimal one.
0.8.
0.8, 1.5, 1.7. Do another decimal one.
0.08.
.08, .15, .17.
8/15.
8/15,
1
1,
and 1 2/15.
1 and 2/15. Would that work? Yeah. Alright, 8/15 is the 8, 1/15 is 15 over 15, 1 and 2/15 is 17 over 15. How about 7/24/25? This is the one that was on the assignment. 14, 48, and 50. That's one that you probably ought to recognize, right? Because it's pretty close to the original there. Usually I call these the 3, 4, 5. You'll hear me call them the head of the family. It's like they're the original member of the family.
168. Wait, no. No, hang on, I'm sorry. 49, 168, my bad. And 175.
Give me another one. 27. 2.4. 2.5. Ignore that straight stupid thing through there.
Couldn't you do .07 and then .24, .25? Is that right or no?
I don't know, is that right?
35. 120. 125.
Are there a whole lot more for each one of those?
Yeah.
Yeah, there's an infinite number for each one. We're not gonna talk about each one of them, cause it's not gonna help, cause you're never ever gonna remember that. Let's go back through some of these. You're probably never gonna pick out that number right there, that those three numbers fit into that 8, 15, 17 triple. It's just not gonna work. You're gonna have to use Pythagorean theorem to solve for the missing part. Alright, write this down, the converse of Pythagorean theorem. And we did some of this last time, if we're trying to prove that a triangle is a right triangle. So if we're trying to prove that a triangle is a right triangle, we're going to use Pythagorean's theorem, but we are going to just plug in all three numbers. New 9 weeks, how many sets of notes should you have in your notebook right now?
2.
2. Chapter 8 review, and this set of notes.
Have we got the review back?
It was review notes,
It
not
was
the review
notes.
packet, review notes. Chapter 8 review notes. Should say chapter 8 review at the top, and then we listed what was gonna be on the test.
Hardly ever write the title down.
That's what you should do, that way you can keep track of it. Makes it easier.
Try to find the right one.
Cause then, if you don't keep them in there, or if you're absent a day, then people come up to me and go, what am I missing? And I go, where's all your titles? Well, I don't write the title down, and then I say, well, I ain't searching through here and figuring out what this is for you. Write the daggone title. It's usually 2 or 3
Well,
words a day.
if they miss a day, then they obviously just need to go back to what you moved. Or ask you at yesterday's notes was not that.
And
Or you
not-
just don't miss school and you don't miss math.
and not come up and ask me.
Or you just drop out and go to Apex.
Yeah, well, that's not what you can't, is that what you're gonna do when you get older? You're gonna drop out of work and go to McDonald's?
I probably work harder than you.
Yeah, well, I'm only 16, so.
I am too. What's your excuse?
Okay, yeah, but I focus on school, so I'm sorry.
If 3 sides of a triangle fit into Pythagorean's theorem, then that triangle is a right triangle. Write down these 3 examples. We're going to do them together. So, if we got 3 numbers, and we're sticking them in, one for A, one for B, one for C. If it comes out to be true where the two sides of the equal sign are equal, then we know that that is a right triangle, or it's going to form a right triangle. My son was out surveying where we're building a barn. He was out surveying it the other day, and he's setting posts in the ground, and I got home after he'd already started,
You always have things like
and he was setting these posts in the ground, and he had a post here, he had a post down here, he had another post over here, and then he had another post over here. Actually, this post was more down here, not up there. And I asked him, I said, okay, what do you got going on here? And he goes, well, these are each set at 10-foot offsets. So this side and this side, there was going to be another, right there is where the corner of the barn was actually going to be. And you set the post out 10 foot so that you got room to work there, so that you don't have to pull the post every time you want, when they come in to grade off the ground and make it level, you'd have to pull the post out, right? Well, if you set it out 10 foot each way, then you can leave the post in there, because then the next time the next person comes in there to lay the gravel out, they still know where the posts are. They're still in the ground there. Then when the concrete people come in, the posts are still in the ground. You don't have to keep taking the post out and resetting them, taking them out and resetting them. So they're 10-foot offsets. So this is 10 foot, this is 10 foot. And I told my son, I said, well, that's stupid. Why would you do 10 foot here and 10 foot there? Why don't you do something like 16 foot here and 12 foot here? Why would I want 12 foot and 16 foot instead of 10 and 10? That fits into 3, 4, 5. Then what would I know about this side right here? It's got to be not 15 times 4 would be 20. It's got to be 20 feet, and I could measure that and make sure that I have what kind of angle right there? A right angle, 90 degrees. That's what these do. What's the first thing you got to look for when you get these three numbers? How do I know which one goes in where? The longest. Which one's the longest? The 9. So make sure you find that first. That's got to be your C. Find it first. So now tell me how to put it into Pythagorean theorem. What am I going to put in for A? 7 squared. Have your calculators out to help me here in a second. Plus 5 squared equals 9 squared. You can do all this right here, all as one thing on your calculator. Punch into your calculator. 7 squared plus 5 squared.
74.
49 plus 25.
74?
Yep.
Anybody else get that same thing? What's on the other side? 81. Are those two equal to each other? So what's that tell us about these three
It's
numbers?
Not a right triangle.
They don't form a right triangle. So not a right triangle. It's not a right triangle. Next one, which one's going to be the hypotenuse there? 25. So I put 25 over here, 25 squared. What goes over on this side?
15 and 20.
15 squared plus
20 squared.
20 squared.
Equals 625.
all that right there equals 625, you're telling me?
Yeah.
That is a right triangle.
What's on the other side?
625.
625.
And the
So
square root of 625 is 25.
We don't need to know the square root. What do we know about those two? They're equal, so what is it?
Right triangle.
It's a right triangle. Is a right triangle. The last one. How do you know which one of these three is the hypotenuse?
The biggest number.
The biggest number. Now, when they're all under radicals, that's pretty easy to pick out because it's all going to, if you take the square root of them, the biggest is still going to be the biggest, right? So which one's the hypotenuse here? Square root of 5. All right? So when I go to do this, watch closely because you guys letting these radicals confuse you.
It'd basically be like 3 plus 4. Right?
What happens over here? Square root of 5 squared, right? What's on this side?
Square root of 3 squared.
Square root of 3 squared plus
Square root of 4 squared.
square root of 4
It'd
squared.
be 3 plus 4 equals 5.
And why it's right, the 2 and the radical just cancel each other out, right? So you're left with just 3 plus 4
It'd be 7.
equals 5. Does 7 equal 5?
No,
So what's that tell us?
it's
Not a right triangle. Not a right triangle. Now what's gonna happen with a lot of you, how come I put this one on here? Cause it looks like it might fit what? The 3, 4, 5. With the radicals, that doesn't work, right? Not when the numbers are inside. So make sure you realize that. We're checking to see if it is a right triangle or not there. All right, write this down. I'm gonna write this in a different way. The book has it written this way. I'm gonna write it a little different here. A squared plus B squared is less than C squared. Either one of these is correct. The book writes it this way. This might be the way that you want to see it because it makes more sense to you. This one down here is going to be A squared plus B squared is greater than C squared. Sorry, I had to think for a second. Pythagorean inequalities. This isn't going to tell us whether the triangle's a right triangle or not, but it's going to tell us that the triangle is something other than a right triangle. It's an acute triangle or an obtuse, and which one it is. Give me 3 numbers.
8, 10, and 7.
We want to decide whether that's a right triangle, whether it's an obtuse triangle, whether it's an acute triangle. What we can do is set up Pythagorean's theorem. A squared plus B squared. C squared is going to be over here, and I'm going to put this little box in there. Back in 4th grade, when you seen that little box, you knew you were going to put what in there? Greater than, less than, or equal to, right? If it's an equal to in here, then what do we know about those 3 numbers Bobby gave us? It's a right triangle. If it's a less than symbol, then we know that triangle is obtuse. If we know it's greater than, then that triangle is an acute triangle. All right? So let's see. What goes in place of A right here?
Wait.
7
Plus 8 squared
plus 8 squared.
equals 10 squared, or whatever.
10 squared. What is, somebody do all that for us. 113. Anybody agree with that? 7 squared plus 8 squared is 113. We got our box there. What's 10 squared? 100. What symbol goes in there?
Acute. It's an acute triangle.
Greater than, right? The greater than goes in there. So what's that tell us about this triangle if we were to draw it? It's going to be an acute triangle. So that means all 3 angles are acute angles. All 3 angles are acute angles.
Can you look that up there?
So you can figure out whether the triangle is acute or obtuse, even if you're trying to prove it's right and it comes out not to be right, we can tell which one it is, acute or obtuse. We're not going to do a whole lot with this. But if you were out working on a job and you were trying to make a right angle and your number came up a certain way and you thought, man, that doesn't form a right triangle. Could you now tell which way you need to move to make it a right triangle? Yeah. If you're at an acute angle, then we want to spread it out more to make it the right angle. If we're at an obtuse angle, then we want to pull it in more to make it a right angle. So you could tell which way you need to move a stake or a board or whatever to get it to form that. If you're setting forms for concrete. I set one form here, I set another form here. I'm going to concrete in a pad for a basketball court or something at my house. So I do this, and I measure this distance right here. I know this distance, I know this distance, I can know that distance. I plug into this, and I come out with this side's, let's make it something easy. Let's say this side's 8, this side's 15, and I come out with the fact that this side over here is 16. Could I stick it in here and know that that's not going to form a right triangle? Yeah, cause it should be 8, 15, 17. Alright, so I know it's not gonna form a right triangle. What kind of triangle is it gonna form, an acute or obtuse? Acute, because my board apparently is a little bit too far that way. So what's that tell me I need to do to the board?
Shorten it. Or kick it out.
Kick it out this way, towards the end over here. And then I'm gonna get closer to that right angle. Let's try these real quick. The first one, 5, 13, and 9. Which one goes in place of the C? 13. Now I wrote these backwards. I should have just turned them around. What goes in place of A? 5. What goes in place of B? 9. Somebody do all that math right there for us. 106. What's 13 squared?
169.
169. What symbol goes in here?
Greater than 13 greater than.
That greater than, right? The C is greater than that, so what kind of triangle is that? Obtuse, everybody agree with that? If the C side is bigger, let's see, let's go back and look at this real quick. I went the wrong way. Previous.
No, it's not.
If the C side is bigger,
It's obtuse.
it's obtuse. Remember, we turned them around,
Oh, I
so,
put it backwards.
alright? So it's an obtuse triangle. So that would be an obtuse triangle. Let's do the next one. What goes in place of C right here? Sort of hard to tell, right? Because the radical 12, what do you know about the square root of 12? Probably need to do it on your calculator and just see about what it is, right? It's smaller than 7, isn't it? So if it's smaller than 7, which one of these has to be our hypotenuse? 7 squared,
That's like
4 squared, plus square root of 12 squared. What is this?
Plus 12.
So that's gonna be plus 12, 16 plus 12. What is 16 plus 12? 16 plus 12, 28, right? 49. This one right here is bigger again, right? So what kind of triangle? Obtuse again. The C side's bigger, then it's an obtuse triangle. Last one, 2, 8, 15. Before I even go into this, anybody tell me something about this triangle before we do all this work?
If it's in one of the things,
Can't be a triangle, why not? 8 plus 2 is what? It's not bigger than 15, so this is not even a triangle. Not a triangle, because any two sides of a triangle must add up to be more than the third side. If it doesn't, then do we even have to bother deciding if it's acute, right, or obtuse? No, it's not a triangle. So make sure you check stuff like that. Remember the rules that we covered earlier this year. On this worksheet, we got about 10 minutes. I wanted to have a little more time than that, but we wasted some time.
What about those papers you said you had?
I'll pass them out here in a minute. I will work some of these problems, look through them. I know Hunter doesn't want me to do any of them for him. He likes doing all his homework himself. I didn't say you didn't. I said, I'm trying to pay you a compliment, and here you're getting all defensive. What did I say? I said he likes to do all his homework himself, right? So look through this, and I will
What's today's date?
try to do some of them for you here in a minute. Give you the right one. This isn't the same one you had the other day, is it?
I don't know, it looks like it.
Yeah, it sort of looks like, some of it looks like, I just got two piles up here and I got myself all confused.
You could have gave us the other one.
I'm not sure why I got two piles like this. Try some of them. Here in about 1 minute, I'll start answering questions. Any of you want to see work? So be ready to ask.
Is C always the bigger?
Yes.
Might want to ask me some of the harder ones, so you don't have to do them all by yourself. Alright. None of them,
35.
you understand them all completely? 35. I stuck that on here. Oh, no. That's on the next part. What is the length of the diagonal of a 10 by 15 rectangle? What's the first thing I should do on this one?
Say 35.
Yep. What's the first thing I should do on this one? Maybe draw a what? Rectangle. Draw your picture. Draw a rectangle. What'd they tell us about this rectangle? One side is what?
10.
The other side is? They want to know the length of this diagonal right here. Do I even need this other triangle over here, really? We could get rid of that if that's confusing you. Where's the right angle at? Here, here, here.
Right there. Don't lay it out.
That one, right? Where's the hypotenuse at then?
Drawing arrow.
That's the diagonal, right? So how could I set this up?
10 squared plus 15 squared equals
10 squared plus 15 squared equals c squared. Somebody do all that right there on calculator for me.
uh, 325.
That equals c squared. Now what?
I take square root of 3.5.
Take square root. Those cancel, you're left with c.
Thank you.
Give me the decimal answer since I didn't specify. 18 point what?
Oh, 2.
02. Close enough. Next question. Go ahead, Hunter.
Sorry, but number 2 would be not a triangle.
Number 2, let's just try it real quick. On number 2, which one's got to be the hypotenuse?
13.
So we do square root of 13 squared,
But
square root
you
of
can't do that because
6
plus
squared
It's not a
plus the square root of 2 squared. What happens here?
6 plus 2 is not.
What happens here?
Cancel out.
Cancel out, what are you left with?
That's 6 plus 2 is
6,
13.
what happens here?
So it cancels out.
Cancel out, what are you left with? 2,
That's not triangle.
what happens here? It is a triangle, but what are you left with?
13.
13, what's 6 plus 2?
8.
8 equals 13, is that true? So what is it? Not a right triangle. Don't say it's not a triangle.
But I thought that the
It's not a
triangle
right
equal
triangle.
More than 13.
For a right
6
Well-
plus 2 doesn't equal 13.
That 6 plus 2 is not our sides. Square root of 6 and the square root of 2 are our sides.
Oh.
So we can say it's not a right triangle. Now, it might not be a triangle, but do we know that? No, we haven't figured out the length of each side unless you know what square root of 6 plus the square root of 2 is off the top of your head. Probably not. Right? Next question.
Next one.
4. Which one's got to be our hypotenuse there? 14. Everybody agree with that?
Yeah.
Why not 15? The radical 15.
Square root.
Okay, if you take square root of 15, that's something like less than 4, isn't it? So 14's got to be our hypotenuse. What's going to be A then?
It's radical.
Radical 15 squared. What's going to be B? Radical 5 squared. What's that leave us with over here?
15 plus 5 equals 14, which is not true.
What's 14 squared?
196.
196. This side's 20. Is that a right triangle? No, it's not a right triangle. Next question. Give me some harder ones. We only got 5 minutes.
41.
41. An isosceles triangle has congruent sides of 20 centimeters. The base is 10 centimeters. Find the height of the triangle. So if I got an isosceles triangle here, what's this angle called? An isosceles triangle?
Vertex.
Vertex angle. We know that these two sides are called the what? Legs, good. What'd they tell us about those legs? 20 centimeters. And the base is 10 centimeters. They wanna know what's the height. How am I gonna figure out the height? Where's it gonna start at?
The center at the bottom.
It's gonna start right here and it's gonna go straight down to there. What's it gonna form? Right angle. Now what's it do to this opposite side? Bisects. So how long is this part? 5. How long is this part? Do I have 2 triangles there? What's the length of this side and this triangle? 5. This side and this triangle? This side? We don't know. That's what we're looking for, right? Which one's the hypotenuse?
20.
So tell me how to set up Pythagorean theorem.
Somewhere between
20.
5 and 20.
20 squared.
20 squared on that side,
5 squared.
5 squared
Plus x squared.
plus x squared or plus b squared, whichever. What's 5 squared? 25 plus b squared equals,
400.
now what do you have to do?
Divide.
These are the ones that you guys are gonna mess up on, some of you.
Minus 5 would be 375.
Subtract 25 on both sides, you end up with b squared equals 375. Now what do you do?
X squared root of 75.
Take the square root of that, what do you get?
19.86.
19.4, let's say. Does it make sense for that height right there to be 19.4?
Yeah.
What's it gotta be less than? 20. Is it less than 20?
Yes.
Do next time, and I will not do a whole bunch of them, so don't forget to do it.